Alrighty, let's re-adjourn here, get into the next section. Anyone want to unmute and just say hi so that I know that you're with me?
Still here.
Hi, Mike.
Thank you. All right, we got some people along for the ride. Okay, so we just completed breakout 1. And we're going to go into section 2 here. And we're going to talk a little bit about setting and merging. All right, so working in SAS, when you want to stack data or combine data within the data step, you have the set statement and you have the merge statement. In R and in the tidyverse, you have the functions bind rows for set, and for merge, you have a family of join functions. If you're used to proc SQL, and if you're used to how SQL joins work, that's very much so how joining in R is considered. So starting with the simpler one, we have set, also known as bind rows. So if we have data frame 1, and data frame 1 has the variables A, B, C, D, E, and then if we have the data frame df2, which has the variables A, B, C, D, E, then bind rows is going to take df1 and stack it on top of df2. So it's going to be in the data sets are going to sort in the order that you declare, or they're going to stack in the order that you declare them. So the first data set on top and the second data set below it. So df1 will stack on top of df2. In merging, you have the family of join statements here. So in data steps in SAS, you're used to if A or B, if A, if B, if A and B. So you have that way of declaring the different statements. So the join family of functions in R is very much so the same as the join family in SQL. So you have inner join, you have right join, you have left join. Jessica, now that I'm looking at this, is this the slide that was wrong? Now I have to check my sanity.
No, it's right, left. It's, sorry, you had right,
full.
left. Yeah, it's full.
Okay, I think that we had outer join on the slide when we were at
yeah, originally, yes, and I updated it.
Okay, very good. Sorry, everyone. Jessica and I had a moment yesterday where we're like, one of these things is wrong, isn't it? Now I'm remembering that this was an issue that we addressed. So inner join is going to only take variables. that belong to A and B. So if A and B. Right join is going to say if B. So it's going to take all values that are in the data frame B. Inner join was A and B. Left join is going to say if A, so only rows that were existing in the data frame A when you're joining them. And full join is going to be if A or B. So you have those two things together, so then you have those ones together. So that's the overlapping between the data frames. So this was a very short section. So we're going to throw you right back into start working on breakout 2. So in this section, we're going to combine two data frames using bind rows. So you're going to be doing your data frame setting. You're going to write some code to do an inner join, which is going to keep both rows from both data frames. And then you're going to make a new data frame and change the code to a left join. So let's go back into our Studio Cloud. So down here in the Files tab, can you all tell that I just figured out how to do this little circle highlighty thing yesterday? This is very useful for presenting to emphasize where I am. So back in Projects, we're going to go into Breakout 2. So we have that available here. You click into Breakout 2, and again, we have the answer key, we have the blank file where you can write your code yourself, and we have the helper file where you can start from to fill in the code. I'll open up the helper file here. Whenever you're programming, you do have the ability to full screen or minimize these different tabs. So just know that you can minimize the console if you don't want to look at that. But in Breakout 2, combining data frames, that's where you want to be right now. Make sure that all your libraries are loaded. Libraries don't unload unless you restart your session. And you can restart your session from session restart R. By the way, if you ever mess up your environment, you can restart it by using that. Control-Shift F10 is also my best friend. I use it constantly because that'll just restart your session for you. But down here, we have this section that's going to do some data loading and some data preparation for you. So we're going to introduce some new data frames in the environment, setting you up for what we're going to do in this session. So we're going to have DM and total DM. We're going to have AE cardiac, that's filtered to cardiac disorders, and AE TAC, which is filtered to AED code equals tachycardia. And then that first section, you're going to stack the two data frames together. So you're going to stack DM and total DM. What is the purpose of doing that? If you see, we converted ARM to total here. So when you're trying to do tables that have a total group, the common technique there is to stack the data frame on top of itself, where in the total data frame, you've renamed all the treatment groups to total. So those two on top of each other. We're going to conduct an inner join. And what we didn't discuss in the slides that I should definitely add to the slides is how you do by variables. So that's going to use, when you do an inner join, when you want to say what you join by, you're going to provide that as a character vector. This character vector is using a function called the vector function, which is C in R. So if I want to create a character vector of just values of character strings, I'm going to use the function C to do that. Let's go back, and I'm going to assign that to variable X. And then you can see in my environment that I have X here, which is equal to a character vector of A, B, C. So this is actually admittedly something that gets a little confusing because a lot of times here, when we're joining two data frames together, when we're referencing variable names, we're not using quotes around them. Well, we're actually going to do that here when we're joining two data frames together because what we're doing in this join of AE cardio and AE inner join is joining the variables using uSubjID and AE seek. So in the character variables for the by, section here, you're going to use them as a character string. To explain why we do that, it's because if you're doing more complex joins, in R you can actually join by variables that are different names. So let's say the values, you have AE, what's a good example of this? Situation where if let's say that you had some source data and your variable, your seek identifier was just seek in one data frame and it was AE seek in another data frame, you could say joined by, for example, in this spot, to say AE seek equals seek, and that would say that the data frame in position 1 is AE seek and the data frame in position 2 is seek. But for the purpose of this, I'm just trying to explain the logic behind that because it's a little counterintuitive from the other things that we've been going over. But in the by variable, you're going to fill in using the vector function C for the join variables. So just like on the data step, when if you say you are merging data frame A and B, then you would have the by variable that you established there. And then in the by, you would say what variables you're joining by. So in here, that's how you provide that. In the helper template, it maps that out for you a little bit so that you can figure that out. So if it feels confusing, work from the helper. If you need to see how that works. And when it's complete, hop over into the answer key. So we have that there. And then we're going to create a new data frame using left join as the last question in the assignment here. So take your time, read the instructions. If you have any issues, speak up, pop a question into the Q&A. Again, this is breakout 2 in the breakout 2 folder that we have there. So this one's relatively short. I'm gonna set a timer for about 7 minutes here so that we can go through that. Let us know if you have any issues, and then we're gonna power into breakout 3. We still have breakout 4, so we have a little bit more to get through here. So we're gonna move right along. All right.
So just a really high level question. I'm noticing like you have blocks of, I guess, comments throughout this code. How does R determine what's, I guess, executable code and what's just comments?
It is the pound sign.
The pound sign.
Yeah, and in SAS, you probably have a shortcut function on hand to comment out different lines. When you're in code, Control-Shift-C will automatically comment out that line for you. And you can do that in blocks of code too. But it's the pound sign that declares a comment. And if it's a comment, the code highlighting will turn that green in this view. I virtually never use light mode though. So whatever the
what about like line 50 though? Line 50 is before the pound sign and it's
line 50. Okay, so in the R markdown, when you're outside of the code block, let me just get this back into outside of the code block that you see here. This is something called markdown. And that's why it's called R markdown, because the code is executable code blocks that can run your R code. Outside of that, you have markdown. So markdown is a markup language, kind of, maybe. It's its own little thing. But what that is actually saying at line 52 is to make it a header. So that, let me show you. Let me actually run. So you have line 17 says intro. When you run that, those two pound signs there are making that a level 2 header. So 1 pound sign creates a heading 1, 2 pound signs creates heading 2, and then with nothing else, it's just standard text. So that's how this text file is then rendering into this document that we have available there. So Markdown has its own relatively simple syntax.
Okay, so the executable code is just specified by like the block that you said?
Correct. So the executable code in a Markdown document starts with 3 backticks. Backticks generally create a block. So without the R, it would just be a text block that just shows as like monospace text. This little bracket that you see there, open and close, if that that symbolizes this is our code. So that's the file telling our Markdown that this is our code. So it identifies it then as a code block. And so the editor will see the highlighting around that.
Gotcha. Okay, thank you. Will this project be available after the seminar is over, or?
Yes. So I will leave it where it is for about 2 days. And then what I'm going to do is move the projects into your personal workspaces. I think that so it'll remain active. It's just we have some extra resources in this workspace that we're working in.
Oop. Cool, thanks.
There's a way that I can put this into your own personal workspace. I'll figure that out later. But
Hello?
hello.
Can you look at my breakout too? I still did not be able to read in the data.
So Alice, I'm gonna kick you out quick.
I know you mentioned about that is to read in from whatever.
Yeah. Are you what? Do you wanna? You have breakout 1 helper here. Did you want to run the answers, or do you want to run?
I run the answers. I'm trying to run the breakout 2 answers, right? See that?
Right. So at line 21, you have this load data. I'm here.
Right.
You got to run this chunk. So there you go. Now that's in your environment.
Oh, so the arrow is when you are pointing to at that point, then it will show up. Right. I see that there's recording, but the recording is available to us.
The recording of the workshop.
Uh-huh. It's 4 hours.
Margaret or Sean, is the workshop being recorded? All of the material that we have here, including all this code, is persistent and will be available to you after. But it is being recorded. Okay.
Not the recording
Okay.
for seminar, but for the event, it is recorded.
But I see a recording button. And
But
it is-
NC Biotech is not going to do that. So that
Oh, so they record it, but it's not open to attendees, right?
yes,
Okay.
We did plan to capture the Q&A and send that out. And again, all of the material from this is available to you after.
This session is being recorded.
Thank you, Sean. So Sean indicated that it is being recorded.
It's being recorded, but it's not available to us, right? Is that what you mean?
Margaret, the question there is, does Pharmasoc have any plan to publish the recording after the fact?
no, not for seminar, because we are trying to kind of protect the instructor. I mean, if you record it and you make it available to those who have not paid for the fee, it's not fair. So
Oh, I mean that is, okay, you mean that people will share, right?
yes,
I mean, because they record the presentation, so I don't understand that is why presentation is different.
yeah, presentation is different, and that the presentation for tomorrow is good till January 31st, 2023. So you have like 2.5 months, but not the seminar. Sorry.
Okay.
All right, so to keep on going through here, we're going to go into the next section. Jess, I'll take this one, then you can do the last one. All right, so now how do you create new variables? So we're going to talk about mutate. We're going to talk about multi-level conditional statements and a little piece on column processing versus row processing to explain a little bit of the difference of how R and SAS process data. So when you're adding or editing a variable, the function that you're going to use within the tidyverse is called mutate. So mutate as in I'm changing the data frame. So this general syntax is going to be the variable name equals and then whatever assignment and operation that you're going to carry out on that variable. So to start here, why is this different than the arrow? And the reason for that is that when you're saying C, that's a parameter of the function mutate. So the equal sign is going to be used as a parameter of the function versus the arrow, which would assign a variable C back into the environment outside of the data frame. So you don't want to get the context of that confused. But in here, so in mutate, I'm going to say I have variable C, and I'm going to say that C is equal to B plus 10. So you can see in here, we have the column B. So in column B, we have 5, 10, 2, 7. And then in the new data frame that I have here, variable C is created, which is the variable B plus 10. So where B is 5, C is 15, 10, 20, 2, 12, 7, 17. So that created a new variable in the output data frame that we have produced. Now, in this, another thing that we're doing here is to create, is to edit variable A. So A already exists in the data frame. So when I'm using mutate, it's going to overwrite the variable A that's existing in the data frame. Just like in a data step, if you modify a variable that already exists, it's going to change the variable that was present in the data frame on your set statement or when you were merging the two variables together. So here I'm going to surround the value in the text of A and dashes. This is using a function called paste0. You can think of paste0 like cat s in Sass's string manipulation functions, but we have the cats function. In R, we're going to have paste0, 0 meaning no spaces between the text when you concatenate it together. So I'm going to say dash concatenated with the value in A, concatenated with another dash. So on my input, we see x, x, y, y, and then we have dash x dash, and I'm going to stumble over saying that as I try to go through that, but you can see the dashes. So rounding the values in A in the resulting data frame. So how do we do conditional logic? So in here, in the mutate function, we're going to create a new function called level. So we're going to have level equals, and then we have a function called if underscore else. The general syntax of the if underscore else function is your condition. So what is my conditional logic? Here I'm saying where b is greater than 5. The second field is what the value should be if b is greater than 5 is true. So we're going to say high. The third field is what it should be if the condition is false. So we're saying if b equals 5, then assign level to high. If b is not equal to 5, assign level to low. So here we have b is greater than 5. That's being assigned to low. Why? Because it's greater than and not greater than or equal to. The second row is 10. So b level is set to high, 2, low, 7, high. So we have that general if underscore else condition. And that's how you handle those single cases of if else when you want to have that conditional logic. What happens if you want to do cases with, or if you want to do more than 2 cases of if else? So if you have multi-level conditional logic. One way would be to do this really ugly nesting, where we have if b is less than 3, then low. Otherwise, if b is greater than 8, we have mid, and then otherwise high. So you can nest those things together, but I'm not even going to focus on that more because don't do that. That's ugly, and it gets you into many, many levels deep if you have a lot of different conditions. So of course, dplyr has an additional way that you can do that. I'm using a function called case when. If you're used to SQL, again, you have an advantage here if you're a SAS programmer who has embraced using proc SQL. Then this is generally kind of the same of when you're using case statements in SQL. So the general structure of a case when statement is that you have the condition, or you have the level, you have level, and then you have the case when function to say if b is less than 3, use this tilde to say then. So if b is less than 3, then the value should be low. If b is less than 8, then the value should be mild. On the end here, you have true. Why true? Because you're saying otherwise true when these statements evaluate the logic. So b is less than 3, b is less than 8, then it cascades down to true, which is the catch-all. So that's saying otherwise, essentially. So you have otherwise, then set to high. So go ahead.
I have a question. When we say that true here, otherwise, I mean, how the SAS work is for the rest, all the values it assigns the high. Let us say that we have a missing value. Even the missing value will be given as a high.
Yes, I say hesitantly. I'm going to check my logic there. Because missings can be, so missings a lot of times do have you handle things a little bit differently. So let's say 2, 3, and A. Right, so I got a date frame. is greater than 2, then yes. True. Yes, 2. I'm terrible at coming up with things on the fly to do that. Yes. Okay. So your answer is true is a full catch-all even for missing values there.
Mhm.
So the logic
And,
of that is that when it goes through, it sees A is greater than 2, and then true just by default evaluates to true. If that is not present, then you do get NA variables there. So
But you
you
can
see-
establish that that's a condition for missing, right? And then you catch it then.
Mhm. So you can specifically handle so there, okay, so this ended up being a good pedagogical example. So if A is greater than 1, then I'm saying yes. So the only number here that was greater than 1 was 2, so that gets the value yes. If it's NA, I'm saying this was missing. So you can see here, this was missing. And then the catch-all here is true, so for everything else, so 1 is not missing, 1 is not greater than 2, so it gets that everything else value there.
And if you want to avoid negative, sorry. If you want to avoid negative number, you can say 0 greater than A less than 1 or whatever. You set a boundary, right? You can have upper bound and lower bound too, right?
So, okay. This won't work. So let's say that's not going to, that condition isn't going to evaluate because that's not valid syntax in R. If you want to do that, you would say X is 1.
Right.
So X is less than 0, or X is greater than 0, and X is less than 5.
Mm-hmm.
So
Mm.
there's
Okay.
you need to do it. I think I can't remember if SAS does that or not. You need to separate the statements. The long-winded answer, and I'm not going to go into that, is that this is actually a function, and it's a function that has a left-hand side and a right-hand side argument. So the syntax doesn't evaluate. It needs to have those two sides to it. So you need to use and or to handle those situations appropriately.
Thank you.
And in the SAS, we have one more issue when we have a case when we are creating. So what is the first variable value we give? The length will be fixed on that, basing on this. But in this example, I can see that it is not the case. Do we have any rules of that having length, limited length or something when we are creating the cases or something?
Nope. There are no variable lengths in our data frame. So that concept just doesn't exist here. So the actual cap on the variable length is going to be something like 32,700 something characters, because of just that is more so how the character string stores in memory. A SAS data frame, the structure of it has that length construct built into how it's stored under the hood. So it's essentially no variable lengths in R.
So hi Mike, can we assign length if we want?
When you're writing out a data frame, when it's to an R data frame, you don't need a length because it's still an R construct. When you're writing out an XPT file, you can assign a variable length. That's something that actually some members of my team and the GSK team interacted with the Tidyverse team in the Haven library to get that capability added in the Haven, because Haven used to auto-assign it just based on the maximum length of any variable. within the data frame itself, but when you're writing out an XPT file, you can set an attribute on it to assign the length to it. But the only situation that you ever have to do that is if you plan to hand that data frame over to a SAS data set.
Okay, thank you.
And we would not have special missing word values, right? In R. Like the dot A dot B, you know?
No, there aren't special missings. There are typed NAs, but like, so a character NA, there's only one type of NA within. So there's not like special missings, like indicative of what type of missing that is implied to be.
Yeah. So maximum for SAS is 32,000 something for variable, like we say.
Yeah, and it's the maximum allowable. Rx. On all versions of R, the maximum that's the maximum number of elements. All right, that's not going to be the quickest Google, so I'll skip that. But it's the same byte limit that you see in SAS for a single string. But again, there's no at least as the length of a string in a vector, there's no concept of assigning a length for that. All right. So you have case when, and we went over that a good bit. All right.
Michael, I have a question. Could you go back to the previous slide? Yeah, I think for this example, if it's missing, it would be assigned to low, right? Because I think the first condition already applied. If it's missing, less than 3.
Is it in R missing is the lowest?
Missing sort last in R, right? Nick and Jess.
Yeah, I was gonna say NAs come at the end.
Right, take out this condition. This is one of those things that when you're comparing SAS to R, it's gets a bit tricky. Oh, come on. To apply the object of class. Yep, NA sort last.
Yeah.
That's, and I mean, like when you work with CDISC data, generally you don't have NAs in there in the first place. So there are workarounds that you can put in place for this. But so in this case, the thing is that, all right, so is 1 greater than NA? No. Because, and this goes back into kind of the the R is built for statistics. And there's seen articles that have talked about this, that NAs, like, you should not mathematically be able to treat 1 as greater than NA because NA is not a number, so there is no comparison. In the same sense, this is something to also keep in mind. The mean of 1, 2, and NA is NA, because R makes you explicitly state to omit, what is the NA.rm, sorry.
And I always say NARM equals true.
I think I'm thinking Python. So you need to, you often and quite often do need to specify that I want to ignore NAs. So most functions will kind of make you consciously make that decision.
Yeah, I want to follow up, Bridget, this gets to your question that when doing inequalities for numeric variables, are missings considered negative infinity? They will produce, you'll produce an NA answer. I think it's NA, not, there's some other R answers, but it will not evaluate.
So how can
So-
you make R behave like SAS when treating the mean with missing value?
When treating, so
So basically, in your example, that is, it will be 1.5, the mean 1, 2, and NA. That is what SAS will give, right? But how can you trick R so that it will be like SAS?
using this na.rm argument, that's how I can get that mean of 1.5.
Oh, you set a condition to it.
Yeah, it's a parameter. And again, it's where you need to dig into the help menus sometimes. And when you get more accustomed, you'll just get used to the fact that you need to tell R when you want to ignore NAs itself. But here, in the mean function, this na.rm argument says a logical evaluating to true or false, indicating whether NA value should be stripped before the computation proceeds.
Okay. Thank you.
All right. So, and again, digging into some of the SAS versus R comparisons here. R, if you've used SQL, you're going to be used to the, or you're going to have stumbled across the fact that column-wise processing can work different than row-wise processing. SAS in the data step has this kind of unique and SAS-specific paradigm of row-wise operation. In the data step, what the physical thing that is happening behind the scenes in the computer is taking a row out, operating across the row, writing the row out to the data frame, continue. So you have the data loop and the data step loop. R is going to default to column-wise processing. A lot of times you're not going to notice this, and kind of the fun part of this slide was that my first example of what I wanted to put in was not an example of a difference in column-wise processing, because that's not how it worked. So here is an example of what that actually means. So in the when you're doing taking your data frame and then you're putting it through mutate and saying I want C to equal the mean of A and B. You might mentally be thinking that I want C to be the mean of 5, the mean of the two of 5 and 5, or the mean of 16 and 10, or the mean of 3 and 2, or the mean of 3 and 7. That is row-wise processing. So the way that R is going to interpret the mean of A and B, there is going to be the mean of all values in A and B, because that the vector of C, A, B is actually taking what that will look like behind the scenes would be the values 5, 16, 3, 3. So all values in A followed by all values in B. So 5, 10, 2, 7. So all of those values together, that mean comes out to 6.375. But if you want to do row-wise processing, you have this function row-wise. So what that's going to do is say, okay, now I'm going to start looking at my data, at this data as the row-wise processing. So here, if you do this together, it's saying C is now equal to the mean of A and B together, and look at those things together. So it's the same syntax. So we've just said, okay, now I want you to treat things as rows, and you'll get the values that you're expecting. So we have 5, 5 is 5, 16, 10 is 13, 3, 2 is 2.5, and 3, 7 is 5. As you go through that. So generally, what I suggest to you when you're going forth and doing your R programming is to try to not focus on this too much. So first try to do things without triggering row-wise. Don't get into the habit of getting hypersensitive to it and thinking I need to consider everything as row-wise processing, because that dramatically slows down operation because vector-wise processing is highly efficient. When you could do everything in bulk vectorized operations, like generally when you use mutate, how that's going to work, then you're good to go. But there are those circumstances where you need to treat things as rows. So if the interpretation of what you're doing isn't working in column-wise processing, then row-wise is available to you to start trying to process that. All right. that brings us to breakout 3, and we want to chug along here because we're at 12:14. We have 45 minutes left. So in breakout 3, what you're going to do is derive the safety flag using if-else. You're going to derive use subject ID by concatenating text from separate columns, and you're going to use DM to derive a unique subject identifier, to derive the safety group. I'm using the 3 categories used in case when. So hopefully we're starting to get the hang of this. From the project folder, you're going to click into breakout 3, and you have your 3 different files here. We're using that same data that's loaded. Make sure you're running your data at line 22 again to bring in a fresh copy of raw DM. You have instructions here of what things should look like as you go through. So in the helper file that we have here, we're going to prepare you guys with the functions that you're going to need and hints to you what you should use here. So if you look in the helper, it says hint, the paste 0 function can be used to concatenate strings. This is a good opportunity to either type help, paste 0, or you can always open up the help menu for a function using question mark and then that function name on the console. So enter that text in and bring it up. And either one of these will work. If you click into, to go back there, concatenate strings, just click that link in, and it'll bring you into the menu to tell you what that should look like. And then when you come down, you can look at the help menu for how the paste functions are working. So we'll go ahead here. I want to get through section 4. So we're going to take 10 minutes for this, and then we'll reconvene. We're here if you need us for questions. So dig in, and we'll gather back as a group in 10 minutes. Alice, I'm sorry. I was in your project and I just kicked you.
I just reconnect that.